Today we're going to look at using right triangle trig to solve for angles instead of sides. For the warm-up, draw a triangle that meets this formula and solve for r. So this is a review of solving for sides. So first we're going to start with the right triangle. And let me stick our right angle in here. And I'm going to call one of my angles 27. It doesn't matter which angle, I'll just put the 27 degrees here. We know that cosine is adjacent over hypotenuse. So if our angle is down in this corner, the adjacent side is the side next to our angle that's not the longest side, so this will be r. And our hypotenuse is the longest side across from the 90, so this is 8.5. And then it says to solve. So to solve, we're going to cross multiply. So we have 1r equals 8.5 cosine of 27. And we can type that into our calculator. So we have 8.5 cosine of 27. And we get 7.57. You should check and make sure your leg is smaller than your hypotenuse, and it is. So today we're going to use trigs to find an angle. It's actually pretty easy. Let's do the first example. Find the measure of theta. Theta is just a Greek symbol that they sometimes use instead of x. So first step, we look at our angle and we designate our sides. The longest side is the hypotenuse. The other side next to your angle is the adjacent side. So again, if we think about SOHCAHTOA, we have adjacent and a hypotenuse, so this is cosine. So we're going to say cosine of our angle, theta, equals adjacent over hypotenuse. To get rid of the cosine, to get theta by itself, we do something called the cosine inverse. So this will be cosine inverse, looks like a little exponent, -1 of 6 over 10. And that's it. You can type that in your calculator, cosine inverse of 6 over 10, and this gives us our angle. So that angle is about 53.1 degrees. So to summarize, to solve for a side, remember from the warm-up we cross-multiplied and solved. And to solve for an angle, we are going to do something called take the inverse. Which looks like this right here. So let's do several examples. Find the measure of each angle to the nearest degree. So here, let's just practice getting rid of sine, tangent, and cosine. So they already did the fraction part right here. To get rid of sine, we do sine inverse. So A equals sine inverse of 0.5688. And you just type that in your calculator. Sine inverse of 0.5688. And we get 34.6 repeating around that, so it's about 34.7 degrees. For the next one right here, B equals tangent inverse of 5/4. And again, all you do is type that in. So tangent inverse of 5 over 4. We get about 51.3 degrees. And the last one, to get rid of cosine, you do the cosine inverse. So C equals cosine inverse of this 0.5774. Let's type that in, cosine inverse. And the decimal is 0.5774. And our angle is about 54.7 degrees. All right, so again, to get rid of sine, cosine, or tangent, to solve for an angle, you do the inverse. Let's try these problems in context. So number 2, find a to the nearest degree. We have this triangle right here inside the circle. So I'm going to start with my angle. Like the side problems, we have to assign our sides O, A, or H. So this is our angle. Here's the adjacent side. Here's the opposite side. So if you think about SOHCAHTOA, this is tangent. Tangent of A equals opposite over adjacent. To get rid of tangent, we do the inverse. So A equals tangent inverse of 20 over 34. And we type that in. So we'll do tangent inverse, and it was 20 over 34. And we get about 30.5 degrees if we round. Let's try the next one. This is angle Z right here. This whole thing is 18, but it's cut in half. So really this side right here is 9. And we're looking at this triangle right here. So we have the adjacent side is 9. The hypotenuse, which is across from the 90-degree angles, is 40. So here's the hypotenuse. We have A and H, so that's cosine. Cosine of Z equals the adjacent side over the hypotenuse. Z equals the cosine inverse of 9 over 40. So cosine inverse of 9 over 40. It's about 77 degrees if we round. Let's try a few more. So again, we're going to look at the triangle, start with the angle. So we have to draw the picture. A 40-foot tall tree casts a 28-foot shadow. What is the angle of elevation to the sun? Okay, so here's our tree right here. Here's the shadow. We want this angle right here called X. It's a 40-foot tree, casts a 28-foot shadow. Start with our angle. We have the opposite side. We have the adjacent side. So again, it's tangent. Tangent of X equals opposite over adjacent. X equals the tangent inverse of 40 over 28. Type that in. Tangent inverse of 40 over 28. And we get 55 degrees. Two more examples. And these angles are marked, actually there's 4 more examples. These angles are marked with this line right here, so I'll just put an X here. We have the hypotenuse, the adjacent side, that's cosine of X equals 12 over 15. X equals cosine inverse of 12 over 15. So we'll type that in our calculator, cosine inverse. 12 over 15. We get about 36.9 degrees. Our triangle might be turned around a little bit, but that's okay. This is X right here. We have the adjacent side and the hypotenuse. So again, cosine. Cosine of X equals 5 over 8. X equals cosine inverse of 5 over 8. And you just type that in. Cosine inverse 5 over 8, 51.3, and 2 more word problems. A roof is constructed in the diagram. Find the pitch, the angle of elevation of the roof. So X, we have opposite, we have adjacent, we have tangent, equals opposite over adjacent. X equals tangent inverse of 12 over 18. We're going to type that in. So tangent inverse of 12 over 18. We get about 37 degrees, I'll round to. Well, let's see what it was. 33.7 degrees, not 37. 33.7 degrees. And the last one, this angle right here is the same as this angle down here. So we have opposite and adjacent, again tangent, equals 5 over 120. X equals tangent inverse of 5 over 120. Type that in. Tangent inverse of 5 divided by 120. The angle is small, it's about 2.4 degrees. So again, to review, if you're solving for an angle, you'll take the inverse. Sides we cross multiplied.